Today's lesson we are going to look at Physics 1604, the Broglie wavelength, lesson 102. Let us start. Lesson 101 of this topic, we looked at the derivative of this equation. The Broglie wavelength is described by this equation, where this is the wavelength, this is the Planck's constant, and then this is the momentum of the object. Now we know that momentum is equals to the product of the mass and the velocity of an object. And then the constant, Planck's constant, is equals to 6.63 times 10 to the power negative 34. The SI unit is joules second. So plugging this to the equation, we are going to have it's equals to Planck's constant divided by the mass multiplied by the velocity. So in this lesson video, we are going to look at practice questions where we apply this equation. Suppose we have this 3 kg object moving this direction at the speed of 30 meters per second. How do we determine the Broglie wavelength of this object? Constant divided by mv. 6.63 times 10 to the power negative 34 divided by the mass, it's 3 kg, and then the velocity is 30. The wavelength is 7.37 times 10 to the power negative 34. Now we know that the wavelength is measured in meters. So this is the answer to the first example. In this case, we have an object which is 200 grams in mass, and then the wavelength of the object is 3.01 times 10 to the power negative 2 meters. And then what is the velocity of the object? This is example number 2. You can pause the video and try to work out this question. Play the video to verify. Now, how do we convert grams to kilograms? We divide by 1000. So 200 grams divided by 1000, it will be 0.2 kg. Remember the basic SI unit, the mass should be in its kg. So when you are given in grams, you should convert before you substitute. So the equation is the wavelength equals to the Planck's constant multiplied by the momentum. So we have 3.01 times 10 to the power negative 2, it's equals to 6.63 times 10 to the power negative 34 divided by the momentum. So when you cross multiply or multiply each and every term by the term causing the fraction, multiply by p both sides, this will get rid of this. Then we divide by 3.01 times 10 to the power negative 2 both sides. This will result into 1. So we have P is equals to 2.203 times 10 to the power negative 32. This is our momentum, which will be in kg meters per second. Then from here we can use the equation of momentum to calculate the velocity. 2.203 times 10 to the power negative 32. It's equals to the mass, it's 0.2. Then you're looking for the velocity. Divide by 0.2 both sides. The velocity is 1.101 meters per second. No, actually, it's a very small value, which is times 10 to the power negative 31 meters per second. An object having the Broglie wavelength of 1.003 meters. The mass is 2 kg. What is the kinetic energy of the object? Now we are going to use the equation of the Broglie to calculate the velocity. Remember that kinetic energy is defined by this equation. Ek is equals to half mv squared. So in this case, you don't have the velocity. Now we need to calculate the velocity using this equation. So we have 1.003 is equals to 6.63 times 10 to the power negative 34. Divide by the mass is 2. And then we're looking for the velocity. We are going to multiply each and every term by the number causing the fraction, which is in case is 2v. Then this will get rid of this. Then we are going to divide by this term. Instead of dividing by 1.003, we are going to divide by 2 multiplied by 1.003. It's actually this 2. So the velocity of the object is 3.305 times 10 to the power negative 34 meters per second. Ek is equals to half mv squared. Ek is equals to half 2 multiplied by 3.05 times 10 to the power negative 34 squared. It's actually 3.305. So the kinetic energy is 1.092 times 10 to the power negative 67 joules. That's it for this lesson video. This is Wahula SJ. Thank you very much.